Hello everyone, welcome to the next lecture. In this lecture, we shall see problems related to percentage. This is an important topic, so we have split this topic into two parts, that is part 1 and part 2. So in this part 1, we will see 15 problems and the remaining 15 we will see in the next part. Okay, we shall check the concepts and formula. Percentage represents how much a quantity is relative to another as a fraction of 100. That is, percentage is equal to part of some quantity divided by total quantity into 100. And to express x percentage as a fraction, we have x percentage is equal to x by 100. Whenever something is given as percentage, we have to divide by 100. For example, if there is a circle and we have to consider 1 quarter, then 1 quarter can be represented as 1 by 4 into 100, which is equal to 25 percentage. So here 1/4 represents 25 percentage. And similarly, when there is some x percentage, for example, when there is some 35 percentage, it means it is 35 by 100. This is also equal to 0.35. So this is the concept. Next, if a certain value p increases by x percentage, then the increased value is 100 plus x percentage of p. Similarly, if a certain value decreases by x percentage, then the decreased value is equal to 100 minus x percentage of that value, that is p here. For example, if p is increased by 25 percentage, it means the new value will be equal to p2. Let me write as p2 will be equal to 100 plus 25 percentage of p, that is 125 percentage of p. This is nothing but 125 by 100 p, again it is 1.25 p. It means the new value is 25 percentage more than the old value. Similarly, if p is decreased by some 30 percentage, then it means new value will be equal to 100 minus 30 percentage of p. So this is equal to 70 percentage of p. This can be again written as 70 by 100 of p or 0.7 p. So if p is decreasing by 30%, it means the new value is 0.7 p. Okay. We can also write, for example, if it is 105 percentage, this is equal to 105 by 100. This is also equal to, when we divide by 5 on top and bottom, this will be 21 by 20. This is also equal to 1.05. So all these values are same, that is 105 percentage is equal to 105 divided by 100 or 21 by 20 or 1.05. All represents this value. Okay. And similarly, if it is 0.8, this means 80 by 100, or this is 80 percentage, or this is same as 4 by 5. So all are same here. Next we shall see another concept. This one is quite important. Here, if the price of a commodity increases by r percentage, then the reduction in consumption so as not to increase the expenditure is r by 100 plus r into 100 percentage. Here it means when the price is increasing, you have to reduce the consumption so that the total cost is same. And next one, if the price of a commodity decreases by r percentage, then the increase in consumption so as not to change or decrease the expenditure is r by 100 minus r into 100 percentage. So to elaborate this, if p represents the price of a particular commodity and q represents the quantity, then the product of p and q will be equal to the total cost. So it means when p increases, that is the price of a particular commodity increases by r percentage, then the quantity should be reduced by r by 100 plus r into 100 percentage to maintain the same total cost. This is the concept. Next, similarly for the decrease, that is if price of a particular commodity decreases by r percentage, then the quantity can be increased by r by 100 minus r into 100, so that the total cost will remain same total cost. So we can see when the price is increasing, we can reduce the consumption, and similarly when the price is decreasing, you can increase the consumption. Finally, we have to maintain the total cost same. Now let us quickly see how this formula is derived. Let P be the price and Q be the quantity of a commodity. Therefore, PQ will be equal to total cost. Let it be C. Okay. Therefore, the initial price and initial quantity will be equal to total cost. When the price is increasing by R percentage, then P2 will be the new price, which is equal to 1 plus R by 100 into P1. So we shall see the new price and new quantity should be equal to the same cost C. Therefore, P1 Q1 is equal to P2 Q2. We shall substitute P2 here. P1 Q1 is equal to P2 is 1 plus R by 100 P1 into Q2. We can cancel P1 on either sides. Therefore, Q1 is equal to 100 plus R by 100 into Q2. We shall rearrange this. Q2 is equal to 100 by 100 plus R into Q1. I am swapping the variables. Okay. Now we have to find out the percentage reduction in consumption. Okay. Percentage reduction in Q or consumption. This is equal to Q2 minus Q1 divided by Q1 into 100. Let us see. We shall substitute the values. Q2 is equal to 100 by 100 plus R1. 100 by 100 plus R minus 1 divided by 1, because we can cancel Q1 throughout into 100. So therefore this will be equal to 100 minus 100 minus R divided by 100 plus R into 100. This is percentage. Therefore this will be equal to minus R by 100 plus R into 100 percentage. So this negative represents we have to reduce the consumption. Therefore percentage reduction is equal to R by 100 plus R into 100 percentage. Similarly, if R is decreasing, then the percentage consumption will be increasing. Therefore, the denominator will have 100 minus R. Other than that, the concept remains same. So put in simple terms, if P2 becomes 5% more, that is 1.05 P1, then Q2 should be inverse of this 1.05 Q1. Then only it will get cancelled together. That is P2 Q2 will be equal to, when you multiply this, 1.05 will get cancelled. So it will be equal to P1 Q1, which is the total cost. So whenever one value is increasing, the other value should decrease accordingly, so that the total quantity will remain same. If they are asking to find the percentage reduction, then you have to use this formula. Next we shall see the result on population increase or decrease at a certain rate per annum. This is the last concept. We shall quickly check the formula. Let the population of a town be P now, and suppose it increases at a rate of R percentage per annum, then the population after n years is given by P into 1 plus R by 100 power n. This is like compounding effect. Similarly, if the population is decreasing at a rate of R percentage, then the value is given by P into 1 minus R by 100 power n. For example, if the rate is 5%, that is increase, then the population after 3 years will be 1.05 into 1.05 into 1.05 of the original value, let it be P naught. So this is equal to 1.05 cube P naught. So the formula is written in different form here. It is equal to P into 1 plus R by 100 power n. Okay. Now with this concepts and formula, we shall start solving the problems. Okay. We shall continue in the next lecture. Thank you.